Okay, we're going to be looking at some things that we'll need to know as we move into calculus. Just should be mostly review for you. Mainly I want to look at functions and function notation and make sure we're clear with that. But I do want to start with interval notation, which we use quite a bit, and hopefully you're familiar with this notation for subsets and sets of the real number line over real numbers. And so we have a set builder notation here on one side and the corresponding interval notation. So when we talk about a set of objects, we use curly braces to denote a collection of objects, and if there's a finite number you can just separate those objects with a comma. Our objects that we're dealing with are going to typically be real numbers, the set of real numbers or a subset thereof. So when we talk about intervals, though, we're talking about a particular set. In this case, right, this says the set of what? X. X is the variable here. And then there's a vertical line here. This vertical line in mathematics basically just means such that or given. And there's some condition after it. So that means such that or given. And what is the given condition? A is less than or equal to X is less than or equal to B. So A and B are going to be some given real numbers. X is our variable. Basically this is saying what? The X is less than or equal to B, but at the same time greater than or equal to A. So it's between A and B inclusive, we say. So it could be A, it could be B, or anything in between. Right? That's what we're talking about. So maybe, A is 1 and B is 3. It would be all real numbers between 1 and 3, including 1 and 3. Now in interval notation, the way we denote that is if we think of the lower number, the smaller number, A, like 1 as in my example, that's sometimes called the left endpoint. We write that, comma, the right endpoint, the larger number, which would be 3 in my example. So 1 comma 3 would be example. Okay, has to be in that order, smaller first and then larger always. You can't have the larger one first and then the smaller one. It has to be smaller and then larger. And then now these are what we call brackets, right? Or hard parentheses, I don't know what you want to call them, but brackets. They indicate that we include the endpoints. We include the endpoints. So this is saying the interval from A to B, including A and B. So this would be any real number in between A and B and including these endpoints, we say. This is what we call a closed interval. A closed interval. And it's a finite interval in the sense that it has a length we can measure, right? If I'm going from 1 to 3, what's the length of the interval? 2, right? From 1 to 3, 3 minus 1 is 2. So we can talk about a finite length in that sense. There are infinite number of values, though, of real numbers. If we're talking about real numbers again, that's what we're talking about here, sets of real numbers. Between 1 and 3, for instance, there's actually an infinite number, which is a property of the real numbers that we have. But this indicates, right, that we include the endpoints. Now, in this example, what's the difference? The set of all x such that what A is less than X is less than B. X is strictly between A and B. It can't be A, it can't be B, but it can be anything in between. So again, we have the left endpoint is A, right endpoint is B with a comma between, but this time we use soft parentheses or just parentheses. This indicates that we do not include the endpoints. So if this was 1 comma 3, this would be everything between 1 and 3. It wouldn't include 1, it wouldn't include 3, but it would include something like 1.1 or 2.98 and so on, anything in between 1 and 3. Okay. Now, this is an open interval. Okay, this one here was closed. When we include the endpoints, this is open when we do not include the endpoints. Both of these are finite. Again, the length is just B minus A. Now, one thing you might say is, hey, this looks awful like an ordered pair. Like if I'm plotting, if it was 1 comma 3, isn't that the point? 1 comma 3, X is 1, Y is 3. Isn't that confusing? Because an interval from 1 to 3 is something different. It can be, but in general, the context of the problem would be pretty clear. When we're talking about intervals, it's pretty clear that we're talking about intervals when we're talking about points or ordered pairs. In the sense of plotting points on the in the rectangular coordinate system, that's pretty clear. If there's ever any confusion, you should ask for clarification, but it should be pretty clear. Now, in this case, we have the set of all x such that A is less than or equal to X is less than B. So we're including A, the left endpoint, but excluding B, the right endpoint. So it's everything between A and B, including A. And so we got bracket on A, parentheses on B. So this is, we can say this is half closed or half open. I don't know. It depends on the way you look at things, right? If you're an optimist, maybe it's half open. If you're a pessimist, it's half closed. I don't know. Still finite, though. Now, I want to look at some intervals that are not finite. These are unbounded intervals in all these cases. It's another way of saying these are bounded. It's probably a better word than finite. Bounded intervals here. And these then become unbounded, all of these. And these all are bounded. So here's the set of all x such that x is greater than or equal to a. So we're talking about a and anything greater than that. So we have a left endpoint is a, and we're including it, so it's a bracket. And then what, up to what's the right endpoint? Well, there is no right endpoint. There is no right endpoint because it goes on forever. It says everything greater than or equal to a. There's no end to it. So to indicate that, we use this symbol, which is the infinity symbol. This is not a real number. Infinity is not a real number. You cannot plug in infinity into a quantity. It's not a real number. So since it's not a real number, we always have to use what? Parentheses. We can't include infinity. This is just a notation to indicate that this is an unbounded interval. It starts at a, includes a, but it's anything greater than a or equal to a. This now is what? Everything strictly greater than a, so it's similar. We're going to put parentheses on a, still have the infinity symbol again with parentheses. The set of all x such as x is less than or equal to b, now we have a right endpoint, but we don't have a left endpoint. When we don't have a left endpoint, we use the symbol minus infinity to indicate that we're b, right? We're including b on the right, but everything less, right? Going all the way back, there's no left endpoint there. Okay. It's real important that negative infinity can only appear on the left, positive infinity can only appear on the right. Can't have those in the opposite order. If you're talking about all real numbers, then we have this notation, right? From negative infinity to infinity, we say, but it's all real numbers. So these are things that you should be familiar with. A couple other things when we're talking about these types of sets, we'll often take a look at this symbol here, which looks like a U. It's the union symbol in set theory, and it means or. So if I want to connect and talk about several different intervals that are disjoint from one another, not overlapping, then we like to use this union symbol. Okay, very infrequently you'll see an intersection. Intersection is and. So if you have two or more intervals up here and you look at this symbol between those intervals, it means and that means whatever's common to all the intervals. What's the common overlap of all the intervals? That's a rarer thing that we see in calculus typically, but a lot of times we'll use this union symbol. This symbol here is the Greek letter epsilon. And basically it means is in or is an element of. So if I were to say something like this, that x is an element of, is a member of, and I gave the set from, let's say, -3 to 2 bracket, then x can be anything that's between -3 and 2 and including 2. It can't be -3 or anything less than -3. It can't be anything greater than 2, but it can be anything in between these two numbers. And it could also be, and or could be 2. And so that's what that means. I already mentioned the vertical bar means such that or given that, and that's used in that set builder notation or set notation. Okay, so most of you I think are familiar with that. Let's just review and make sure we can understand it. Can you write the appropriate interval notation for this? Yes, this says what? 5 is less than or equal to x is less than 8. Our left endpoint is 5. Our right endpoint is 8, and we do need to put the symbols, right? Do we include a bracket or parentheses here? Less than or equal to, right? So x could be equal to 5, so I need a bracket. X is strictly less than 8. Don't include 8 parentheses. Okay, so there's my interval notation. This is the set of all x such that x is less than 2.7. So I don't have a left endpoint. So remember what we do in that case. We use the minus infinity symbol, and then my right endpoint is 2.7. I always have parentheses on infinity or minus infinity, and in this case x is less than 2.7. I've got a parentheses on this as well. And then this set of all x such that excuse me, x is less than or equal to 4/5 or x is greater than 8. So this one here, what's our interval notation going to be here? less than or equal to 4/5. Again, no left endpoint for so minus infinity. The right endpoint is 4/5. Okay. What do we do here? Always parentheses, right? 4/5. Do we include it? X is less than or equal to? Yes. Bracket on that. Right. And then we've got an OR. What's the OR going to be? Well, we talked about it up here. The OR is the union, and so we use this little symbol here to join these guys together. Or what? X is greater than 8. So what do we have? We have 8 is our left endpoint, our right endpoint. There is none, so we use infinity. Do we include 8? X is greater than 8, so no, parentheses on this. So this is the way we would write that set. So if we have 2 or more intervals that don't overlap, we will use the union symbol. So X, if X is in this set, it can be anything in this one or in this one. Okay, so hopefully that's clear. Just as a review, if X is an element of this interval, which of the following are possible values of X? Let's circle all that apply. Well, is it negative 1.5? Well, this says what? Everything between negative 1 and 1, including negative 1. So it can't be anything less than negative 1. And so this would not be included, so I'm not going to circle negative 1.5. Negative 1, is that in there? We just said it is, right? Because of the bracket, we include negative 1. Okay. How about 0? 0 is between negative 1 and 1, so that's in there. 0.9 is between negative 1 and 1. It's real close to 1, but it's still less than 1. Same with 0.999. That's even closer to 1, but it is still less than 1. What about 1? Is that in the set? Again, no, because of parentheses excludes it. And so 1 is not in that set. Just real quick for fun, what's the smallest number in this same set of real numbers? I think we're all pretty clear about that. It has to be negative 1. Negative 1 is the left endpoint, and we're including it. It gets a little tricky when we say what's the largest number in this set. That can't be 1. Again, 1 is not in that set. So the question is there a largest number, a largest real number that is less than 1? And the answer is no. And so there is no largest value. And that might be a little disturbing for you, but again, essentially we can get as close as we want to 1, but we never get there. All right? Think about 0.9, that's close to 1. 0.999 is closer, and so on. I can keep adding 9s on. How long can I do that for? Forever. Right? I'll never exhaust that, but I'll never be at 1. Now, some of you like to think this is true. You think that this number, which hopefully you're familiar with this notation, a little bar over it means what? 9 repeating forever, right? 0.99999. You say, well, that's going to be the largest number in the set. The problem is that is equal to 1. It is the same thing. It is exactly equal to 1. And that's a problem that some of you might be looking at and scratching your head. How can that be? I'll just say very simply that you are not scratching your head, I hope, at this statement. 1/3 is equal to 0.333 forever, right? And you can get that by dividing 1 by 3 using long division if you remember how to do that. But that's certainly true. If both of these things are equal, if I multiply both sides of this equation by 3, I get an equivalent equation, right? Which is also true. And notice when I multiply this by 0.3, I get 0.999 forever. Multiply 1/3 by 3, I get 1. So it is true, if 1/3 is 0.3333 forever, 1 is equal to 0.999 forever. And that's maybe a little disturbing, but it is true. And so real important, there is no largest number in this set. It is a property of real numbers. Okay. So with that review of intervals, which we'll use here in a minute, let's review real quick what it is to be a function. So a function is a rule or set of instructions, basically what we call a relation, that assigns each value in one set called the domain to exactly one, real important there, put that emphasis there, exactly one value in another set called a range. Okay. Now when we talk about relations relate, if you will, two variables together, but a function is a special type of relation because for each value in this set called the domain, there is exactly one output, we say, or one value in this other set called the range. Now the independent variables or input, those represent arbitrary values in the domain, and the dependent variable or output represent arbitrary values in the range. Okay. So those are terms that you should be familiar with, and I've got them underlined and bolded. You need to know what these mean. So when we talk about functions, we name them. We talk about the squaring function, absolute value function, cube root function, etc. Typically we use letters, don't we? And that's, when we start using letters to represent functions, you have to move up in sophistication mathematically and understand there's a difference between a variable and a function. They are related, but they are different. And that's troublesome because we now have letters representing functions and letters representing, of course, variables. Now, when we typically talk about functions, a lot of times we like to use the letters F, G, and H, but any letter could be used. When we talk about variables, we typically like X and Y, but we use other letters too. So it could become confusing at times, and so you need to be very clear which is which. Now, the output of the function f when x is the input is written this way, and it's real important. You've seen this notation, I hope, before. This is pronounced f of x, right? F of x. And this is not a multiplication. This is not f times x. A lot of times you hear of, you think that means multiplication. It can't be multiplication. F is a function, x is a variable. You cannot multiply a function by a variable quantity. A function is a set of instructions, right? This is not f times x. This is f of x. This is saying take x, which is what? X is an independent variable. It's coming from the domain. It's an arbitrary value in the domain, and we're essentially plugging it into the function f. Right? So the idea is, I've got the function is sort of like a black box here, if you will. I'm inputting x, a variable. F is a function. It's not a real number. It's a set of instructions. It tells what to do to x. And then we output what? We call that f of x. Okay? So the parentheses are kind of like the holding bin. Whatever's in the parentheses, what we're plugging into the function. So this is not multiplication. You have to get that clear. Some of you algebraically are more sophisticated or have better experience with your algebra. Others not so much. You've got to get those things cleared up. You cannot struggle algebraically or you will have trouble with the calculus. Okay, it's also called the value of f at x, the value of f at x, or sometimes the image of x under the function f. Okay, so for example, the squaring function can be written as f of x equals x squared. Now this equal sign here is not so much an equation here as it is an assignment. In other words, when I plug in x, I determine the output, which is f of x. So the f of x, the whole thing, is a variable itself. It's a dependent variable. And the output is what? Take the value of x and you just square it. That's what happens in the box, right? If I plug in a 2, right, f of 2 is going to be what? Square 2, 4. F of 2 would be equal to 4. And that's what it says there. Now, sometimes the f of x notation is not used, as is in the function y equals 4x minus 2. Here, y is the dependent variable. So here in this case, we say y is a function of x, right? And so we would say y is equal to f of x. We could say that. So y is now a variable. So f of x, that's a variable. F is not a variable by itself, so I can't write that. But I can do f of x, that's a variable. It's the output to the function f at x. And so y equals 4x minus 2 is a function. Y is the dependent variable, x is the independent variable. Okay, so you should be familiar with this. Let's see how this works in a couple of instances. Suppose I have these two functions, f of x and h of x, and let's answer parts a through d. Let's find f of 5. So we're going to use this function. The input x is 5, and you know how to do this, I hope. Wherever we see an x, we're going to replace it with 5, right? Here's what's in the input in the parentheses, right? So I'm going to take that, multiply it by 3, add 4, and then divide by that input squared. So I'm going to have 4 plus 3 times 5 over 5 squared, right? And now I do the mathematics. Of course, this vertical line means division, and typically we do division before addition. However, here we're going to do addition before we do the division. Why? Because there is really a parentheses around this. We don't usually write that, but it is implied when we draw this long horizontal line that everything up top is done first, everything at the bottom is done then, and then we divide. Or top and bottom are done sort of simultaneously. So here I would do what? Multiplication first. 3 times 5 is 15. So don't do the addition first. 4 plus 3 is 7, and then multiply by 5. No. 3 times 5 is 15, plus the 4 is 19. And 5 squared is 25. Right? So make sure that you're doing the correct order of operations. Okay? And if we're looking at a functional value, you should leave it in a fractional form. You can estimate, with your calculator if you want to. In certain cases you want to do that, but certainly give the exact value. What about h of -1? So now I'm going to plug it into here. H of -1, everywhere I see an x, I'm going to replace it with -1. And here I need to be careful with order of operations, right? So here, what do I do first? Multiplication, addition, subtraction, what? No, exponents first, right? Exponent, -1 squared. What is -1 squared? That's +1. -1 times -1 is +1. So that's real important, because I've seen a lot of people do, well, negative times negative is positive. You're doing the multiplication before you do the exponent. You can't do that. You've got to do the -1 squared first. So what do we get? 5. Here I can do the multiplication. 2 times -1 is -2. -1, so now I can add, subtract left to right. 5 plus -2 is 3. 3 minus 1 is 2. So there's my output. When I plug in -1 into the function h, the output is 2. Sometimes our input is a variable itself, like in this case, h of 2t. So what do we do there? No problem. Wherever we see an x in our original, we're going to replace it with 2t. So this will be 5 plus 2 times 2t minus, and be careful here, what do we need to do? 2t and then just square it like that? No, we've got to put that whole thing in parentheses, which is important, because without the parentheses, 2t squared is not the same thing. This is 2t times 2t, which is what? 4t squared. And so I get 5. 2 times 2 is 4t minus 4t squared. Okay, and there's my output. I'll leave it like that. Of course, if we're inputting an expression involving t, it's no surprise that we get an expression involving t as an output to the function. And then for d, let's find all the values of x such that h of x is -10. Such h of x is negative. So how do we do this? Up to this point, we've been finding outputs given the input. Now, what do I have? This is the output. What's the input? And so if I go back to h of x, right? H of x is this function, 5 plus 2x minus x squared. That's the rule. So that output is going to be input x, output 5 plus 2x minus x squared. That has to be equal to -10. So that's what h of x is, right? And now what do I have? Now I have an equation. I have an equation, right? Equal sign, expressions on either side I need to solve. So what type of equation is this? This is an exponential, sorry, not exponential. This is quadratic equation, sorry. It's a polynomial of degree 2 equation, and everyone should know how to solve these. Okay? You have to be able to solve equations algebraically. I do not want you to simply plug it into the calculator, use some sort of app, or cheat on that. You need to know how to solve polynomial equations like this, quadratic equations, how to solve trigonometric equations, how to solve exponential equations, how to solve logarithmic equations. You'll need to review that because those will come. Okay. So how do we solve this? I'm going to set everything equal to 0. I'm actually going to subtract 5, subtract 2x, and add x squared and put everything on this side. So I get 0 equals add x squared, subtract 2x, and subtract 5. -10 minus 5 is -15. So I did several steps there in one time. Hopefully everyone's clear. I just put it over on this side so my negative x squared becomes a positive x squared. And the reason I want to do that is, how do I solve now? Well, some of you might be saying, use the quadratic formula. No, I would avoid using it if I can. If I can factor this expression, I would. Or I would complete the square in this case, because the coefficient of x squared is 1. Since it's set equal to 0, we can use the zero factor property if this factors, and indeed this factors, right? X squared I know is going to be x times x, and now I'm looking for the last two numbers, what? To multiply together to give me -15, but they add together to give me -2. So what is the answer? One is positive and one is negative, right? And the -1 is bigger, it's -5, +3. -5 times +3 is -15. -5 plus 3 is -2. And so now the important thing is, if you have a product of two things equal to 0, you know one of them has to be 0. That only works when it's equal to 0. If it's equal to 1 or 2 or anything else, there's an infinite number of combinations that you can multiply to get those non-zero numbers. So be careful about this. So this simply says, by the zero factor property, that either x minus 5 has to be 0 or x plus 3 has to be 0. Right? Of course, here I have x is 5. Here I subtract 3, I get x is negative 3. And so there's my values of x that I can have. And now, one thing we said, notice at the very beginning of the function, we said that for every input there was exactly one output. And that certainly happened in part A, B, and C. For every input there was exactly one output. But here now, we've got an output of negative 10, and there's two different inputs. Is that okay? Is that still a function? Yeah. The input of 5 has one output, negative 10. The input of negative 3 has one output, negative 10. So we can have two or more inputs giving the same output for a function. That is okay. Okay, I am going to, in the next video, take a look at evaluating and simplifying an expression called the difference quotient, which is very important. We are going to do that over and over again. And then we're going to look at the graph of a function and sort of play around with the graphic, look at functions graphically and see if we can interpret it in that way.